We would like to welcome our next speaker, Mamta Kaushik. Mamta Kaushik is Senior Staff Engineer at Nagaro, and she would be delivering an interactive talk session on APIs that think, testing the invisible brain behind AI agents. To know more about Mamta, please go through the below link. I would like to over to Mamta. You can carry on. Thank you.
Yeah. Hello, everyone. Let me share my screen.
Sure.
I hope my screen is visible to everyone.
Yes.
Yeah. Hello, everyone. A very warm welcome to all of you. It's amazing to have such a diverse global audience with us today. I'm Mamta Kaushik, and I'm working as Senior Staff Engineer with Nagaro. There has been a lot of exciting discussions today from AI agents, MCPs, Playwright with MCP servers, AI-driven automation. Now I want to take you one level deeper into the layer that quietly powers every AI system we rely on, APIs. APIs that think, testing the invisible brain behind AI agents. Let me start with a quick question. When an AI agent gives you a wrong answer, who do you usually blame? The model or the API? Most people say the model, but in most real world failures, the issue is not the model, it's the API. The part we don't see, but the part that shapes what AI agent understands, interprets, and decides. I learned this the hard way. Few months ago, we were testing an AI-driven workflow assistant. Something simple like, updating a user profile. Everything was perfectly in isolation, but the agent failed consistently on one step. After investigating, we found the issue was not the logic, it was the documentation. The API supported patch, but the docs only showed post examples. And the agent inferred the wrong structure and kept sending an invalid payload. So nothing crashed, nothing was technically broken, but the agent made the wrong decision because the API didn't guide it. And this was just one kind of failure. Agents also struggle when API names are inconsistent or the patterns break, schemas drift, or the behavior becomes unpredictable. So documentation is just one part of a much larger problem. And that's exactly what we are exploring today. So to keep this simple, I have structured the session into 3 parts. Problem: why agents fail today, even when APIs work perfectly. We will look at some real-world failures, documentation gaps, and the growing issue of API drift. Followed by the solution, how APIs should be designed, documented, and how testing needs to evolve. Lastly, the recommendations, something that you can take back to your teams. So before we dive into our first topic, we will discuss why this matters for testers. As testers, we are entering into a world where our test cases are no longer the only source of truth. Agents depend entirely on what the API tells them. So if our APIs are unclear, inconsistent, or incomplete, the agent will expose that failure instantly. By the end, you will know how to test the APIs so AI agents can understand and trust them. So APIs that are not AI ready, they can silently block automation and growth. If an API cannot be discovered or understood by an AI agent, it does not matter how well the code is written, the agent simply cannot use it. In traditional testing, we validate endpoints, responses, behavior, but now We also need to test discoverability. Can the agent even find the endpoint? Can it understand what the endpoint does? We see this happening in real world platforms. Let's take an example of Zapier's AI integration. Zapier's AI integration engine, it hides API that do not have clear examples or metadata. Some Shopify extensions never even showed up. That's not a code issue, that's a business loss. On the other hand, we have Stripe APIs. Those are predictable, machine readable, and beautifully documented. AI tools love Stripe. Competitors with messy or incomplete APIs, they simply get ignored. I saw a similar pattern in a recent audit, an internal API. It was not showing up in our agent's action list simply because one example was missing from the open API spec. The API worked perfectly, but it was invisible. That's the real lesson. API invisibility leads to missed integrations, blocked automation, and lost business. Now that we have seen the cost of invisibility, let's explore what makes an API discoverable and usable by AI agents. Discoverable APIs are designed for machine comprehension. They give agents enough structure, clarity, and examples to understand the API without a human in the loop. Agent-ready APIs, they usually share a few qualities, like they're complete, they are accurate, machine-readable documentation they have, rich schemas, rich examples, clear semantic metadata, predictable naming patterns, and stable, reliable behavior. And from a testing point of view, each of these becomes something we validate. For example, with machine-readable documentation, we validate the OpenAPI spec itself. Is it complete? Are the examples sufficient? For schemas and examples, we run schema coverage tests, whether all the fields appear in the examples. Semantic metadata, here semantic diffing tools highlight naming inconsistencies that confuses agent. Pattern linting, it helps us catch verbs, noun mismatches. And repeated flow testing confirms whether the API behaves consistently. And we see this in the real world as well. Let's take an example of GitHub Copilot. It works beautifully with documented APIs, but struggles with undocumented internal ones. Because at the end of the day, AI tests only, AI tools can use only what they can interpret. So let's see this with a simple example on the next slide, where we are comparing the traditional APIs with agent-ready APIs. On the left, we have a traditional API. Here, the payload is very short, just title, author, price, availability, which is perfect for a human developer. But on the right, we have something richer: genre, rating, inventory, related items, constraints, and even semantic intent, like category is fiction, intent as book purchase. A human being can read both and figure out the purpose, but an AI agent does not think like us. It relies on patterns, structure, relationships, and semantic cues. The first API, the example on the left, gives almost no context, whereas the example on the right, it tells a complete story, enough for an agent to infer purpose, behavior, and constraints. And that's the difference between a traditional API and agent-ready APIs. Traditional APIs, they assume a human will interpret the docs. Agent-ready APIs, they assume a machine must infer the meaning. And this difference becomes important when we look at how agents fail. Because this is not theoretical. We have already seen how unclear or incomplete documentation breaks AI-driven workflows. Across industries, agents fail, not because the model is bad, but because the API gave them the wrong or incomplete ground truths. So there are few examples that I have listed on the slide. Travel booking bot. This travel booking bot stalls because the agent couldn't infer the right field. Healthcare workflows. Healthcare workflows retrying in loops because examples were missing. Payment retries crashing because the spec drifted from reality. And there are many other such examples like profile updates failing because only post examples were provided, not the patch. These are not code bugs, they are documentation and discoverability bugs.
Sorry,
Hi, am I audible?
yes, I think there is a glitch. Can somebody, yeah, Mamta, you
Yeah,
can join track one again and start.
okay.
We are on the track one actually, yes. Yeah.
Yeah, but I'm not seeing the option to join in track one.
No, no, you are already in a track one, I think.
Okay, okay, okay. So I
Are
should
you
share.
Yeah.
are you
Yeah,
able
yeah.
to share your screen?
Yeah. Let me try sharing it again. Yeah.
Yes,
Is
we
my
can.
screen
Yes, your screen is visible. Go
okay?
ahead. Sorry, I
Yeah.
think there was a glitch in the meeting. Right. Anyways,
Uh, no worries. Sorry, guys. Okay. So, getting back to what we were discussing. So we were discussing about few examples. Few failures that were caused by the documentation failures. So these are not the code bugs that we discussed. They are documentation and discoverability bugs. And this leads us to the bigger and more systemic issue: documentation and reality drifting apart. So, up to 75% of API drifts from their published specs. When real API behavior diverges from documentation, both agents and testers they lose the ability to trust the APIs. Fields appear, disappear in responses. Optional fields enforced like required. Error messages change silently, and these breaking changes hide behind the feature flags. So, this is where agents struggle the most. Not because the API is bad, but because its representation is wrong. So, how do we prevent drift and reduce invisible failures? We need APIs that are not just discoverable, but something that are designed for autonomy. Agent native design means the API teaches the agent how to reason, not just what endpoints exist, but how they relate, what intent they serve, and how failures should be handled. Semantic intent, explicit constraints, related object references, machine interpretable hints, rich metadata for reasoning. This makes the API self explanatory for an agent, not just for a human. And when we design for autonomy, documentation becomes even more critical because it is the agent's ground truth. So, in an AI first ecosystem, documentation is not just a reference, it becomes the spec agents interpret. Missing examples, inconsistent naming, incomplete schemas. These become logical bugs from the agent's point of view. Like few examples that I have mentioned here are missing patch examples. Here, the wrong payload is inferred. Inconsistent naming. Agent chooses wrong field. Incomplete spec. Agent cannot discover the right action. So if documentation is the agent's reality, how do we keep that reality accurate? Auto-generate from traffic. Detect real-world changes and auto-update our documentation. Spec sync workflows. Validate spec versus behavior on every build. Drift detection. Catch unexpected changes before agent 2. Example checks. Ensure examples cover all real fields. Schema enforcement. Keep response shapes consistent and predictable. Imagine a travel booking API. It silently switches a field from a simple string to a nested object. Nothing breaks on the backend, but the agent suddenly starts failing because its mental model is now wrong. Auto generation from traffic notices the new field first. Spec sync catches the mismatch with the published specs. Drift detection. It flags the shape change. Example checks reveal that no example shows the new structure. And schema enforcement, it stops the release. So before the agent ever sees the wrong data, all these techniques work together to fix the gap. These practices make documentation trustworthy for both humans and agents. But correctness alone is not enough. Documentation must also be useful. Useful documentation is structured for human and machine comprehension. Logical grouping of endpoints, clear summaries, field level examples, some constraints list, consistent use of Open API. As testers, we should validate that every endpoint has examples, errors, constraints, and clear intent. Patterns are what LLMs thrive on and what prevents hallucination. Consistent naming, predictable behavior, hierarchical structure. This is what lets agents reason correctly. Uniform verbs like create, update, delete. We should have consistent noun forms. Predictable pagination, stable response shapes, explicit optional fields. Inconsistency leads to hallucination and misuse. Now that we understand design and documentation, how do we test APIs for an AI-driven world? Traditional testing, it checks correctness for humans, whereas AI-first testing, it checks semantics, meaning, discoverability, and whether an agent can reason. For agents, ground truth is whatever the documentation, schemas, and responses tell them. If these drift or conflict, the agents make decisions based on wrong ground truth. Examples like let's say we have to update the customer shipping address. A human calls the endpoint, but an agent, it must infer authentication, fetching profile, identifying correct fields, retrying with validation errors. That's why AI-first testing requires few points like semantic validation. It flags confusing field names. Discoverability testing. It ensures agents can find the right endpoint. AI fuzzing. It generates inferred edge cases. And lastly, prompt path testing. It observes how the agents plans and execute workflows. And when agents act, they don't behave like humans. They retry, loop, infer, and trigger unexpected load patterns. Imagine an AI travel assistant that gets a sudden spike of retries because a downstream service is slow. A human would retry once or twice, but an agent, it may retry 20 times in a few seconds. Nuanced rate limiting. This detects and protects the system. Concurrency caps. It ensures only a safe number of parallel calls go through. Then abnormal pattern detection. It flags the sudden burst as unusual before it turns into an outage. These ensure APIs remain stable when autonomous agents drive the traffic. And all of this raises a question. What is the standard model for agent-ready APIs? MCP, the Model Context Protocol. This is becoming the foundation of agent-ready APIs. It's not the future, it's happening now. Supported by OpenAPI, Anthropic, Microsoft, it wraps legacy REST with semantic capabilities. Think of it like a USB-C type for AI agents. But autonomy also needs guardrails. 95% of API attacks, they come from authenticated users. Agents amplify traffic volumes. OAuth hardening, layered gateways, auditability. Test security flows for both human and agent-driven access. And finally, security is not enough. Autonomous systems must also behave responsibly. Transparent data sourcing, privacy, fairness, no silent failures, predictable behavior, responsible defaults. Agents are becoming regular API consumers the way browsers did 20 years ago. Just like we adapted for web, then mobile, then microservices, now we must adapt for autonomous agents. The adaptation starts with designing better APIs, documenting them accurately, and testing them in AI-first ways. Thank you so much for listening. Happy to take your questions.
Yes, any questions?
Mamta, thank you so much for this wonderful session. What are the key challenges that probably somebody who's trying this for the first time and they would probably face? What is your experience, and can you share some of these pitfalls and challenges for somebody who's going to start doing this or starting this journey?
Yeah. So I think as testers, it's the mindset that, the first that we have to change because we have been testing APIs from human mindset. And that is something that needs to be changed. We need to test it from agent perspective, like how agent is going to, consume the APIs. So that's the main thing that we have to, start looking into and start, shifting our mindset. So this is, one of the, I will say, the challenge, the starting challenge that I face, that shift our mindset and, start reasoning. Like I this explain several techniques like prompt part testing. So several techniques that we have to follow, and we have to start reasoning how the agent will consume these APIs.
All right, thank you so much. There are two questions which have come up in the chat. Rajni has asked, what is prompt path? How we can do? And second is how we can align our document and API.
Sure. So, like prompt part testing, as I mentioned, so it basically evaluates how an agent plans, navigates, and how it executes an entire workflow when it is given a goal, not step-by-step instructions. So, it's agents, they don't behave like humans. They infer the missing steps, they retry, they choose their own endpoints. So this prompt testing technique will help you uncover these failures. And I hope this answers the question of the first question. So the second question, yeah. So how the documentation and API aspects. We test alignment by comparing the documented contract with the API's actual behavior. So that means validating the open API spec against real traffic. Like we should check every field and responses, so whether they exist in the spec, verify the examples with the whether the examples are matching the real payloads, and detect the optional or required fields drift. So these are some like points where API and docs, if they disagree at any point, the agent will learn the wrong ground truth. So alignment testing is very critical in this case.
Thank you so much.
I hope
There's
that
one more.
answers your question.
Rajni,
Sure.
is that okay? Or we can
Yes,
go to the
yes,
next one?
thank you.
Okay.
Thank you.
There is one more from Anil. He's asking how to modify existing API base so that these are AI agents ready. Now, is it quite a challenge? And that's a challenge what basically Anil is saying. How do you solve that?
Yeah, so see, existing APIs that can be modified. So as we discovered, we have MCPs. So what they do is they basically, the legacy, the REST APIs. So they can be wrapped into using MCPs, and there are, certain tools that can be used. So we can make use of existing, traditional APIs only by wrapping them in MCP servers and make them agent capable, agent ready.
Tool,
Does.
did you mention any tool, Mamta, or?
MCP servers. So we can use MCP servers to wrap our existing APIs, the traditional APIs that we have. So MCP servers, what we do with them is basically they wrap the legacy REST with semantic capabilities. So, as I mentioned in one of my example also, it works like a, USB-C port for AI agents. So that will make and that's one of the ways to make our traditional APIs, usable for AI agents.
But wouldn't that actually result into something? Because MCP API servers, which would be given by standard tools, like for example, Jira or for example, Microsoft Teams. But if we are having
Postman also, we can connect MCP server and then we can test.
yeah, but let's say it is an internal APIs. We are talking about our own internal APIs. So how do we get an MCP server for that? Because we don't have that, right? Would it solve the problem in that case or no?
So internal APIs, we can wrap internal APIs behind the MCP capabilities, so we can expose, our platform APIs as MCP capabilities by wrapping each internal API endpoint as a structured tool. So we can define JSON schemas, and MCP will enforce the typed contracts, so agents can safely call those internal APIs. I mean, that's one of the way which I can think of as of now.
In that case, we will have to create our own MCP wrappers around our own APIs.
Yes.
That would be basically something which will require effort from the dev team.
Yes, I mean, designing part will be required in that. Yes.
Okay. All right, guys. And thank you so much, Mamta, for answering that. And any other questions? Otherwise, I think we can request Srimay to bring up the thank you slide and do the honors, please.
Sure. Yeah, thank you, Mamta, for your wonderful session.